The opcode sheet looks like this. You have the instruction opcode, also referred to by the name mnemonic, arranged in alphabetical order, and by the side of it is the hex code. So we will be referring to this sheet, which are 2 pages at the end of your textbook. We are writing our first assembly language program to add 2 8-bit numbers stored in memory locations C000 and C001. The answer obtained will be stored in C002. Now, with the knowledge of the instruction set that we have learned so far, we are going to write this program. So I have assumed that the 2 numbers are 7 and 3 to be added. 7 and 3 will be added to give you decimal 10. In hex, it will be A. Now, the data transfer instructions that work with memory are load accumulator, which moves the value from memory to the accumulator, and store accumulator, STA, which transfers the data from accumulator to the memory address. The add instruction that we will use here is add R. So the 2 values to be added will be stored, one in a register besides A, and the other will be in the accumulator, because add R works this way. R value of the register is added to A and the answer is stored in A. So now we start with our first instruction. The value in the memory address C000 is moved to accumulator. Write the comment. Leave 3 spaces because this is a 3-byte instruction. It has an address, so leave 3 spaces. Next, temporarily move the value that's there. Copy the value from accumulator to B. Write the comment. It's a 1-byte instruction, hence we don't leave any space free. Move this value from the accumulator to B. After that, we are ready to move the next value, that is number 3, from C001 to my accumulator. So I'll say LDA C001. Again, this is a 3-byte instruction, hence I leave 3 places for this instruction. So I copy value or move the value from C001 to accumulator. So my 2 operands are ready in place and I am ready to fire the add instruction. So after leaving 3 places for LDA, because it's a 3-byte instruction, I say add B. So the value that's in B will be added to A and the answer will be stored in A. Done. Now again, add B is a 1-byte instruction, so we don't leave any blank lines. I store the answer that's in my accumulator to the final destination, that is C002. So what do we do here? I transfer the value from accumulator to memory address C002. Again, STA is a 3-byte instruction, so leave 3 places followed by halt. Now the next step in this is, once your program is ready, fill in the hex codes and be very, very careful. When you look into the sheet, that's 2 pages that are at the end of your book, look at the instruction LDA. Find its corresponding hex code. So now we know it is 3A. Yes. Now look at C000, the operand that's with LDA. Take the lower byte of this address followed by the higher byte. the next thing that we do, look again into the opcode sheet and tell me what move B comma A is. In this case, it is 47. Next, again LDA. LDA, we know we have already used it earlier. The hex code is 3A. What's the address? C001. Its lower byte is 01. Its higher byte is C0. Next, tell me what's the opcode for add B. Look into your sheets. At the end of your textbook, it is 80. Next, STA. Again, tell me what's the hex code for STA. It is 32. Write the lower byte of the address followed by the higher byte. Now, the last instruction that marks the end of the program, stop execution, program execution. Refer to the opcode sheet. What's the opcode? 76. Fine. Now remember, in the lab you will not use HLT as the instruction to end the program execution. You will use the instruction RST1. For the simulators, most of the simulators, they support only HLT. Now, after reaching so far, you are ready to feed in this program. When I say feed in this program, means you are ready to feed in this hexadecimal codes into memory location onto your simulator or your microcomputer. Now, where do I feed them? I decide that, okay, C001 to C002 is used for data. So I start my program, say, from C005. The others from 3 to 4, 3 and 4, I keep them unused. So, okay, C005, C006, then C007, C008, C009. After 9 comes C00A, C00B, C00C, C00D, C00E, and C00F. The last instruction will be stored in C010. That's it. So the memory addresses associated with the hex code are what we need actually. In the lab, we will enter these hex codes into these memory locations that are present here. So this marks an end of how you write a program to feed into the simulator or the microcomputer in the laboratory. I hope you have understood.